Okay. So what is the story here? We have a rectangular circuit containing a resistor R. So this is the rectangular circuit. This is the rectangular circuit here. Okay. And this circuit here, we call it rectangular because it has a width B and a length A. Okay. It has R, the resistance R, and the whole circuit actually is moving with a velocity V. And this velocity is constant. Okay. Away from a long straight wire carrying current I naught. So this is actually a wire that's carrying the current I naught. Okay, drive an equation that gives the current induced in the circuit as the function of the distance x between the near side of the circuit and the function. So they are looking actually for an expression or an equation that relate, okay, the induced current here inside. يعني داخل هنا في راح يكون في induced current. Okay, and this induced current inside this rectangular circuit. Okay, how can we relate that one, okay, with the distance between the rectangular circuit and the original current اللي هو الواير هذا. Okay, and what they did, they write an expression called x. X is the distance between the nearest side of that rectangular circuit and the wire, which carries the I naught. Okay, so at the end of the day, we need to see the effect of that. And before we start, actually, we should discuss and ask ourselves what is going on actually. We know, خلينا نروح نشوف صورة الحين شباب. We know from here, okay, as you can see, that if the current is going to the top, okay, and you put your thumb, okay, so this is the thumb here, I don't know, this is the thumb, I'm trying to point there, but you can't see me. Okay. So the thumb is going with the direction of the current, okay, يصبع الإبهام تروح مع الcurrent, and the rest of your fingers, they are circulating or just holding the wire by this way, and from that we can understand the direction of the magnetic field, as you know, and have something you know from before. Okay, but as we go apart, far away from the wire, okay, in this case, that magnetic field will become more weaker, and we know this is actually from Behrens law. Actually, this is very obvious for us. This is not something we don't know. Okay, so the magnetic field here is very weak. Okay, it is a very weak here, B. Okay, let's call B2. And B1 here, okay, strong. It's very strong. You know that. Because we are moving from stronger magnetic field to weaker magnetic field, okay? So that means the magnetic field is changing. If the magnetic field is changing, so delta phi is changing, okay? So we have induced epsilon, and because we have induced epsilon, that means we have induced current. Okay, so this is the story behind this one. Okay. Okay, so again, it's the same story like before. So we are looking for the induced current. So induced current is coming from induced epsilon, and induced epsilon usually it's related to delta phi over delta t. This is something you knew from before. Okay, and you know that this is also related to B into A, okay, or the changing in B and B. And we know that B is changing, okay? The magnetic field is changing. What about the area? Also, the area is changing, ya shabab, in this case. Why the area is changing? Because now the total circuit is moving to the right here. Okay, so now let's take this one out. Okay, so this actually will move. So let's say that this moves like that until that place or that location here. So if it moves like a delta x small distance here, okay, yes, this wire, the B here, the width now, it moves a little bit with the delta x, but we know that this is also an area. Okay? So with this area, we can call it delta A. Delta A, differential area. And differential area, it has a length A into delta x. Okay? So don't forget that. Okay? So that means delta A is changing as we move, okay, as we move the rectangular circuit. But what is the minimum and what is the maximum of that area? This is very important for us. The smallest one, okay, before we start move, يعني قبل أن نبدأ نتحرك, okay, we know that the distance to the near side هنا, شباب لاحظوا معي, distance كان x, فهي البداية كانت عند x. لو افترضنا انه هذه الحركة يعني راح يتلوها حركة هذا الجزء, لا تنسى شباب. شوفوا هذا الجزء المنقط الحين نقط لكم اياه, هذا تخيلي ان rectangular circuit moved by delta x in this side also here delta x, صح ولا لا شباب؟ هي طبعا نفس المنطقة هذه, يعني نفس المنطقة هذه تحركت يعني. اوكي. طيب before it moves with delta x it was at x here, okay, and then delta x. طيب does it will stop at delta x? Actually no, it will still moves until it will finish b. يعني هي بتتحرك كامل عشان تعمل the first movement كاملة, يعني حركة كاملة. الحقيقة هي تحتاج أن تتحرك بالطريقة التالية. خلينا أرسم لكم إياها. Okay. So ثواني بس حتى أنا أرسم لكم شيء واضح بالنسبة لكم. اوكي. هذه تحتاج انها تتحرك بنفس المقدار حتى توصل هنا كاملة. طبعا اذا تحركت هنا معناتها هي كانت هنا, هي بدأت from here and then it reached here. okay. فهي قطعت at this point there x plus b. okay. It starts with x and then it ends at x plus b. إذن for one movement, one total movement لهذا rectangular circuit, it okay, covers the distance from x to x plus b. And then we know that delta area or the differential area is taking with respect to delta x. Okay, as we increase delta x, differential area is increased. Okay, so let's now make the mathematics after we understand it by physics, and that's the most important introduction. Now it's very easy. Now, if you know the story, everything is easy. So epsilon induced equals to, يا شباب, minus and delta phi over delta t. Okay. And we know that this is minus delta phi, n is 1. N is given as 1, I think. Or no? No, it is. Let's get it here. So n is not mentioned, and we see that this is only one circuit, so there is no n's here. So it will be 1. Okay. Delta phi, we know that delta phi is just the b into a, but we know that b is changing in our case, and also a. Okay. It's changing. But we should ask ourselves first of all, okay, what is b? Okay. We know a, or differential area, we know it from there, but what is b? To find b, we know that there is something called Amperian's law. So from Amperian's law, okay, we know that b into 2 by r, okay, in this case is x. Don't forget that one, because this is the distance from here, from the wire, equals to mu naught into I. And actually, this is the magnetic field surrounding a straight, okay, very long straight wire carrying a current. So from here, the magnetic field at that point x, okay, equals to mu naught, which is a constant, into I naught, which is the original current here, okay, divided by 2 by x. Okay, so that is the original magnetic field coming from the straight carrying wire. Okay, so that is b, and then we know there is no n, so again epsilon here equals to oh, I'm sorry, not epsilon. I'm looking for phi. Sorry. Again. Okay, so phi that can relate it to B. Now we know B at that specific location that's coming from the original wire, but actually phi is just the integration of that small b's, okay? Because we know that b's is changing, so B, don't forget, is changing, okay? Because B is changing, so we wanted to add up all of these or sum up all of these, B's in that area. So B into that area. So we want to sum up all of these together. We know that B, sorry, just mu naught into I over 2 by X, okay? And because X is varying, so we should integrate over that X into actually the small differential area that we are looking for, because area is not constant. In this case, also area is changing, okay? So this is also area is changing. So we are not taking fully B or fully A. We are taking small amount of B and small amount of A, which is dB and dA actually in this case. Okay, but we know that these are constants. We know that mu naught I and 2 pi are constants, so we can take them out. So mu naught into I divided by 2 pi. And the integral, it will be only for 1 over x. Don't forget dA, as we said here, it is A into dx. So this will be into A dx, like that. A is also constant because A is the length of the rectangular circuit. So we can take A from there and put it here. Okay? So this is again, which is phi B equals to mu naught I over 2 pi into A. Okay? And the integral will be 1 over x dx. And from mathematics, okay, as you know, this is very well known for you that the integral of 1 over x is just equals to ln of natural log of x. Okay? So from here, this is will be like mu naught I over 2 pi into A into ln of x, but we know that we are varying x from where to where, Shabab? From x to x plus b. So this is will be from x, okay, to x plus b. So the from the lowest to the highest movement distance. Okay. Okay. Now, actually, this is will be like a very easy task now for you. This is will be mu naught to I, okay, over 2 by A. This is will be like ln of x plus b, the top part there, minus ln of x. And we know from mathematics, actually, this is can be also written as, we know that these are constants, 2 pi into A. This is like ln of x, yes, plus b divided by x. Okay. So this is what? This is phi b. So now we know that the flux is changing with respect to x. Okay. And we can actually we can simplify this one a little bit better. So then we can make it mu naught, sorry, I over 2 pi into A, and this is will be like if we divide everything by x, Shabab. So this is will be ln of x over x plus b over x divided by x over x. Okay. If you make that, so then phi b it will be in a simplified form. Okay. Mu naught I over 2 pi into A. Here it will be ln of 1 plus b over x divided by 1, because x over x is 1, so no need to write that one. Okay, so it will be ln of that. Okay, alhamdulillah. So now we find phi b, and then we are looking not for phi b, not for the flux itself, we are looking for the change in flux. So we need to look for the first derivative of that actually. Okay, so how can we get the epsilon here? Epsilon induced. Now this is the important move here. it will be minus n delta phi, as you know, over delta t. You see now, delta phi now is with respect to the time, so the change in time, okay? But we have here the relation between delta phi is changing with x, it's not changing with t. So we need to put some physical trick here, somebody called mathematical trick. Okay. So delta phi over t, it is just like if we can make it like delta phi, delta x into delta x or delta t. Yes, it's mathematical trick, it's not physical, because this is just playing with the functions. So we know that delta x can go with delta x، يعني ما كأني سويت شيء، يعني كأني أنا فقط جالس ألعب عليها حتى أحصل a relation between delta phi and delta x. Why is that? Because we know delta x over delta t, this part here, is just what's يا شباب? Just v, the velocity. Okay. So this is like, so this is delta phi over delta x equals to that one, delta phi over delta t. Okay. So we can take this one out and we put everything, and we'll take this one and substitute it here. اوكي يا شباب، واضح لحد الان؟ فقط هذه العمليه اللي راح نسويها يعني. طبعا we know n is 1, so minus, and this will be delta phi over delta x, delta phi delta x into v. Okay. We know v is constant, so let's take v. V is constant, write it there, no problem. So this is will be like minus v. Okay. Delta phi, phi we know is all of these things here, which is mu naught. Okay, let's write it. Delta over delta x now. Okay. So what is there here? كل اللي كان هنا شباب في البداية اللي كتبناه عن delta phi or phi itself, the flux, it will be here. Okay. So we know that this is mu naught I into A over 2 pi. Okay. And enough 1 plus B over X. حتى ما نلخبط في الأمور، خلينا نعمل خط حاجز بلون آخر. نختار هذا اللون مثلا. We are speaking about that part here. Okay. طيب. So we know this part here, البارت هذا كله شباب هذا constant. So we can take it out from the differential process. Okay. So let's write it now, and epsilon induced equals to minus V, okay, mu naught I into A over 2 pi. Okay. Now we are differentiating what يا شباب؟ على enough 1 plus B over X. Okay. Again, we need to see the mathematics or calculus from here. We know something that رياضيات تخبرنا بسهولة، تقولنا إنه if y equals to ln of x, okay, the first derivative راح تكون يا شباب العكس 1 over x، لكن مضروبة as a chain rule in the first derivative of that function which is inside contained function. Okay, x dash. يعني أنا اللي يهمني مش فقط إني أحصل على الديريفيتيف مال هذه ونور x، لازم أيضا أضرب في first derivative of that. Okay. Okay, very good. So if we can apply that one to this one, هذا معناته if now هنروح شوية يسار. If y in this case, in our case يعني ln of 1 plus b over x. يا شباب. فهذا معناته إنه الواي داش إيش راح تكون in this case؟ أيوه yes تكون 1 over that which is 1 over this b over x. Okay. So this is the first part. Multiply by the first derivative of this. طيب إيش هو هذا أصلا؟ هذا هو عبارة عن 1 plus لو طلعنا الإكس فوق تجي b into x to minus 1 صح ولا لا؟ طيب إيش الفيرست derivative of that؟ إذا كانت هذه هي y الحين في ذي الحالة يعني. طبعا احنا نعرف انه الواي داش هنا راح تكون ايش يا شباب؟ خاصة على هذا. ال1 تكون 0 زايد. هذا الحين بي كونستنت، طبعا هنا عندي ماينس 1 فوق، فبتنزل تحت بتجي ماينس بي، يعني ماينس 1 ضرب بي. الاكس هذه فوق هنا ماينس 1 بنقص منها ماينس 1. So we subtract another one, so it will be minus 2. Okay. طيب بعدين هذا ايش يعطيني؟ بتنزل هذه مره ثانيه تحت بتكون بسكوير. Okay. فهذا معناته this will be like minus b into 1 over، خلينا نخليها مع بعض، minus b over x squared. Okay. الحين هذا اللي حصلناه احنا هو من الماث، انه we have this is 1 over that function as well as the first derivative of that function. Okay. And because we have minus sign here, this minus sign will go to that minus sign. Okay. So let's write this one now. كل هذا الآن راح نكتبه وين يا شباب؟ راح يكون هنا اللي هي the first derivative of that function. Yeah. Okay, so this is will be like minus v mu naught I into a over 2 pi into all of this. 1 over 1 plus b over x into minus b over x squared. Okay. النتيجة النهائية, the final result will be very easy because we have minus sign, that means it will be positive. Okay, so this will be positive, it will not be negative. And because we have x square here, multiply this one b over x, it will go, so x will go, and we left with something called bx, okay, down there. So down, actually, we get bx here, and because we have 1 here, so it will be x squared. يعني هي في denominator there it will be like x squared plus xp. Okay, then we can take x outside, it will be x plus b. Okay, يعني هذا المقام كله بيتحول إلى هذا في النهاية. Okay, at the end of the day we have this is v into mu naught I a, don't forget b, now we have b. Okay شباب لا تنسوا هذا, over 2 pi okay x into b plus x. هو هذا المقام اللي تكلمنا عنه قبل شوية. Okay. So this is what actually, this is epsilon induced. بس يكون هذا واضح بالنسبة لكم. Okay. كل يعني الفيزيكس هنا تقولنا إنه as x increases, okay, here down here, so epsilon will be decreased, okay, because we are going far away from the original current or the original wire. Okay. Now, see, we are looking for I induced actually. So I induced is just epsilon induced, as you know, over the resistance, and we know R. It's given in the question there at the top. Let me see هذا شباب. R, it is given but without numbers, because this is expression. فهذا معناته انه كل اللي كتبناه هنا راح يكون نعيده مره ثانيه. This will be v naught I a b, and actually a b is this the area شباب, يعني we can write the area here and it's the same over 2 by x b plus x. So that is the final result, and don't forget R, because R is the resistance. You get the induced. Okay, no problem. So alhamdulillah, now we have the expression, but we have to understand what is the physics behind, and I think it's clear with you in this case. Okay? But don't forget, I naught here is the original current.